Hey, everybody. Here we are again. This is Astronomy Daily Live, happening every single day at 2 hours UTC, and it is almost 2 hours UTC. I like to come in a little bit early, so I have a little bit of time to get into the groove. And there we go, 2 hours UTC. Ding, 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 ding. Get into the groove and get all my accoutrement together here. So I'm going to go do that. I've got to set up my, I'm going to pop out the chat over here on my Linux machine. Whoop. So many buttons to push. And I'm going to load up the stream on my smartphone. Like that. Should be there. There that is. And there that is. So far, so good. So far, so good. All right, I can see myself on the live stream. Scary vision. And I'm going to pop myself out of the chat so I can use that particular tab for perhaps something else later on. All right, I'm going to do a quick audio check. So I just dug this mic out of somewhere and sort of assembled it in a very crude manner, and I don't have a mic stand, so I'm gonna have to put you down just for a second. I just have to remember to stay pretty close up to it. So all right, we're good. Hey, Bob Dog, how's everything? Hope all is well. Things are going pretty good here. As I said, this is Astronomy Daily Live. This is a live daily stream talking about astronomy for an hour or so. And I was thinking about, the description of this show today a little bit. And there's one thing that I definitely want to add. And I am looking for some screens that aren't appearing. There we go. And I mentioned and I hope that it's sort of coming off. That this is a very casual conversation. It's just a circle of friends sitting around chewing the fat about astronomy for an hour or so. But casual should definitely not imply low quality. This is I want this to be as high quality as I can possibly get it, and so yeah, no real messing around or anything like that. It's fun, casual, but we're talking about some interesting things, and it can certainly become intense at times because that's how the universe is, and that's how the science of astronomy is. It's a pretty intense science because unlike I think pretty much every other science, astronomy is the study of everything, and there are specialties within astronomy, but the science of astronomy itself is the study of everything. And when I was a very young kid trying to make sense of things, it's like, well, I sort of want to know everything. So how do I do that? Oh, it's astronomy. Okay. So here I am, as bewildered as ever. Yeah, but so this live stream is a very casual, skeptical, open-minded, um, hopefully educational and fun um, daily live show, just about astronomy. Um, Maybe get into some other things, if there's a relationship there. I'm going to talk about rocket launches and spacecraft and all of that too. So there's a relationship there. Um, but hey, whether you're completely new or you're an amateur that has been in it for a while, or if you're an advanced amateur, uh, and if you're a pro, you're all welcome here. I want to bring everybody into this. Um, Everybody can learn something, and everybody can contribute. And believe me, the teachers probably learn at least as much as their students, if not more, because in order to teach things, you have to have a pretty decent understanding of it. Otherwise, you're screwed. So yeah. So everyone is welcome into the circle, and this is a circle of friends. This is a chance for us to come together every day uh, and just sit back and talk about everything. Um, so get away from the TV for a while and the news, and you know, think and talk about a subject that you are passionate about. I'm extremely passionate about it, and yeah, it's been my entire life so far, and it's been an interesting ride, and it ain't ending. It's just getting better and better and better. So it's like this continuous upward slope. Yeah, very very cool. Um, Now this is just a circle of friends. So this is a conversation. So it's not necessarily just me. Yak 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 yak. I can do that, no problem at all. Um, uh, you know that's fine. But if you want to bring anything up at all, um, we're sitting around just chatting, right? Um, and I reserve the right too, to chit chat and ask things, and because I certainly am in no position to know uh, a lot at all. So I've got a I've I have a lot of experience, and I have a little bit of knowledge, and I can certainly share those things. I have opinions and ideas and theories and um, my own um, explanations of things. But what I've uh, observed, at least in the podcast slash live stream world of astronomy, is that um, uh, a lot of scientists are sort of put into a position of having to have the answers, and science isn't like that. There isn't a beginning and a middle and an end where it's like at the end we just we know. Um, some and so a lot of scientists are sort of put in a position where they're sort of having to do that, and I don't really think that that's fair, and it definitely isn't scientific. Science is a process. Um, in fact, it's a process fractal. So um, the outputs of this process get fed back um, into the inputs, and it just goes on and on and on and on and on. Um, and that's kind of neat. That's kind of neat. answers lead to more questions, and questions lead to answers, and those answers lead to more questions. You've heard this stuff before. That's what science is all about. It's inquiry, it's curiosity, it's awe, it's wow. It's whatever it is. That's amazing. It's absolutely amazing. So certainly, bring up topics as you wish. We can chit chat about them here. If you want to be on the live panel down, you, I think you'll probably line up here. Just got to drop me an email at cosmiclettuce@gmail.com, and when the show goes live like this, I can send you the link, and you can pop on. Haven't had that opportunity to try that yet, so I'm looking forward to doing that. That's sort of a different level of activity because I'm gonna have to put on um, my headphones and plug into the speaker or the headphone jack here uh, because it's much more interactive than the chat. But if there aren't any major or interesting topics with the circle of friends here, I certainly have many, many, many in my back pocket that is easy enough to pull out, and we can cover those kinds of things too. But we can do Q&A both ways. We can talk about observing. We can talk about gear, telescopes, any kind of instrumentation or cameras, CCD cameras, CMOS cameras, spectrometers, polarimeters, photometers, whatever. There's adaptive optics, all kinds of fantastic instrumentation, both here on the ground and uh, out in space, out in mainly orbit. I don't know if there was any. I don't know if there are a couple of spacecraft that are kind of far out there, but I think a lot of them are in low Earth orbit. Um, so we can definitely talk about those. We can talk about analyzing data and uh, what do astronomers do. You know, they go to work like mostly everybody else, but once they get into their offices, what are they doing all day? Um, we can get into that if anybody wants to. We can talk about different areas of research. Um, Always interesting things there. If you go to archive.org, it's AR. Uh oh, it's ARXIV. Sorry, ARXIV.org. Um, the latest and greatest papers on not only astronomy but most of the sciences, mathematics, statistics, economics. Um, yeah, just that is the bleeding edge uh, of all the sciences, and these are the papers that have been accepted for publication, but haven't been published yet. They're sometimes called preprints, and they are in electronic form, and we have full and free access to those. So it's very, very awesome. That's how I keep up on things going on. I might see or read a news article about some kind of astronomical event or a phenomena or an object or anything else. And usually, those news articles are written for people who don't know astronomy at all, period, um, and don't necessarily want to and don't necessarily care. But there's a pretty picture, or there's something strange, um, those kinds of things. Well, I'll I'll look in the news article, and most of the time there's either like a title of a paper, or they've talked to the author or authors. And so then I'll immediately jump over to archive.org and look for the paper there, and can usually find it. Sometimes they don't set them up there, but they're usually there, and it's a great resource, great resource to keep up on sort of the latest areas of research. Nice to do when you're an astronomer who wants to know everything. So yeah. Um, we can talk about astro-art, and I think if I get a chance, a little bit more of my astro-art. There's a an art show going on next weekend. It's the 2nd, 3rd, and 4th of February 2018. It's at the yeah, I almost combined two words. It's at the University of Arizona Lunar and Planetary Laboratory. It's an art exhibit called the Art of Planetary Science, and so it's an attempt at a merger between art, the artistic uh, um, method, I guess, uh, and science, and in this case, planetary science. So that for the science of studying planets, mainly other than Earth. I mean, if you're talking about the study of the planet Earth, then you're more into geology. Um, Planetary scientists study other planets, other moons, and they're pretty heavy into geology, but they don't limit themselves to sort of the ground, right? They can talk about the atmospheres, they can talk about their orbits, they can talk about their evolution, um, they can talk about how these planets and moons interact with one another, those kinds of things. So planetary science is is a, is about other moons and planets and asteroids and comets, um, but it isn't limited to geography. It's a much broader uh, science than not geography, geology. Uh, it's a much broader science than geology, and encompasses that, but a lot more than just that. So tonight's drink of choice is the famous hydrogen hydroxide, and this is a nice full uh, thing here. So hydrogen hydroxide is sort of my go-to uh, drink. It's very calming, um, and at least from my location, absolutely delicious. So cheers. Looks like I've got a little bit of lag with the stream tonight. I hope that's not too annoying. Not much I can do about it, except just keep it going. And yeah, that's that's the casual aspect of the show. Is that we just sort of we just go with the flow. So cheers. So please remember to like this video, subscribe if you haven't, share it amongst your friends who may be interested in this kind of a topic, and this casual way of doing things. Um, Nothing too serious here, but hopefully high quality, and you know we can get pretty intense if we want to. It's an intense subject, right? So yeah, very cool. So long intro out of the way. this is a learning curve. And uh, as a musician, right? I understand the concept of practicing. It's actually best to practice every single day. So, in a certain sense, I am right now practicing in that hopefully taking these little steps every single day is just going to get better and better and better, whatever that means. Not quite sure what that might mean. Probably has to do with some satisfaction and sort of getting to follow my passion and maybe eventually get to do what I want a little bit more. So yeah, very very awesome. Hope everything's good out there, Bob Dog. Hope all is well with you. Everything's great here. Weather's good. Yep, yeah, everything's awesome. Everything's very very awesome. The got to remind current and future listeners that this show is canceled uh, for tomorrow. For tomorrow, which will be 2 hours UTC on the 28th of January. Um, I'm I'm heading off to do a sweat lodge, and that's going to take up most of my evening. Um, the live stream here goes live at 2 hours UTC every single day, with some exceptions. Uh, so where I'm located in southeastern Arizona, I'm on Mountain Standard Time, and Mountain Standard Time is 7 hours behind UTC, Coordinated Universal Time. So that puts me at a start time of 7 p.m. my time. Uh, so yeah, I only provide you with one time because well, in all honesty, that's all there is. There's just now, and but how we measure now is different, and we have a perception of the passage of time, and since we're on a spinning globe, supposedly, probably, um, we have different local times. So you're gonna have to figure out what your local time is relative to 2 hours UTC, so you can show up here live. And the concept of time is really really important to astronomy. So being able to do something like that, uh, you know, figuring out when the show is going live, may be an obstacle at first, but it's one of those nice obstacles that when you get over it, it's sort of like, all right, did it? What's next? Yeah. All right. Very cool. It looks like the sound is still going. So yeah, there's a art show next weekend, and I've got 4 pieces in it. I've got three prints and one video, and the kind of art that I uh, create. I don't know exactly what to call it yet, but it's sort of um, it looks like sort of becoming a consensus, even with this art show, that it's called data art, and it's art that is created with data, as the name implies. Um, and so, at least in my case, I'm taking like astronomical data and turning it into uh, something that I guess at least resembles art. Uh, Now I cannot draw. I cannot draw for shit, right? can't draw at all. But what I can do is I can write code, I can write software, and I can write software to draw. So that's what I do. So I take uh, various pieces of astronomical data in, and it can be anything, right? I mean, it can be it doesn't have to be an image, right? It can be um, uh, it can be anything. It can be, you know, temperature versus time, and I can do something with that. Or yeah, you know, it's if you think about just you know sort of the realm of astronomical data, it's pretty unlimited, and it's up to the creator, it's up to the artist to try to represent that in uh, in a beautiful way, and so you know that sort of represents uh, the spirit of the data, and so that's what I do. The manipulation of the software is I sort of see it as manipulating the tools. So um, I don't really mess with the paint because the paint is the data itself, but I can manipulate the paintbrush so it paints in a certain way. Um, Maybe with a certain stream of color or a particular shape, um, and I can make up new tools to paint as well. It's pretty limitless, and I uh, I can get pretty lost in it. It, it's kind of fun, and it's even funner for me because I'm in sort of a simplistic way. I'm writing code, so I'm just typing on the keyboard, um, running a script or some kind of a program, um, and then generating these plots or these images or these renderings. Actually I think I like to call them renderings because that's sort of what they are. They're just they're like drawings, right? And so yeah, there's a show next weekend. I got a few of my pieces in it, um, and hopefully people will like it. They'll have hopefully they'll have a some kind of reaction. I'm not really into positive and negative reaction. I'm into the absolute value of the reaction. So if it's a high positive reaction, I like that. If it's a high negative reaction, I like that too, because it's a strong reaction, and I'm more into the reaction than sort of trying to figure out whether this was a positive reaction or um, uh, a negative one. So let me uh, let me throw up some of this art, and yeah, I don't use that word lightly. Throw up. So uh, hopefully hopefully uh, it's not going to be too boring. So let me share my screen, and I'll pop in the first one here. Now these are not the full resolution images because they are digital images. I can actually make them any resolution and any dots per inch that I want. And so the originals of these that I sent to the printer are 8,000 by 8,000, 300 by 3 or 300 DPI uh, um, images because I had the printer print them out on 24-inch by 24-inch prints. So anyway, here's the first one. I'm going to get rid of that. So I call these orbital crystals. And I don't think, let's see how, oh, it's not too bad zoomed in. It's, at this resolution, this is sort of a low res version. Um, yeah, sort of a low res version. So it doesn't, it's not quite as sharp and detailed as the actual print or the raw um, image. But this gives you an idea of at least one of the things that I'm looking at. Now, this image, this rendering, I should say, was created using the orbital motions of the four Galilean moons of Jupiter. I'm going to take a drink here. So what I did is I took the positions of those four moons as they orbit Jupiter over the course of a month. And I created this out of it. So this, it's, yeah, I'm not going to get into the details of how these were. Really, all this is just a bunch of lines. Just for a given time, I have drawn a line between each of the moons. And the thing that makes it interesting is that the orbit of Io is faster than the orbit of Europa, which is faster than the orbit of Ganymede, which is faster than the orbit of Callisto. And so uh, as these moons orbit Jupiter, and I'm drawing lines between these four moons, um, the motions make the lines overlap, and eventually, they fall into these patterns, which, you know, uh, um, when I first saw these, the first thing that came to mind, were like the spirograph uh, things, that maybe you did as a kid. I did those. Um, Interesting thing about these, because it's real data, it's actual data. Um, they're they're sort of imperfect. They're not, you know, symmetrical. They're not complete. Uh, but I think that makes them even more interesting because you look at something like this, and when you realize what you're seeing, and that is the motions of these four moons and sort of the relative motions between them, um, you start to see that there are really some interesting resonances, some interesting patterns. Um, so then, I took artistic license and made the lines different colors, and I rotated this and that. You know, did things um, to, you know, sort of that raw rendering to make it look neat, at least to me. So you can actually see here. This is the orbit of Io, this smaller one here. For some reason, my mouse thing isn't working too well. Here's the orbit of Io. Here's the orbit of Europa. Here's the orbit of Ganymede, right? And here's the orbit of Callisto. So it's as if you were looking down, and Jupiter would be in the center. Um, so you're sort of looking down or looking up. Uh, but I sort of like to see this as I'm above it and I'm looking down. Of course, in space there is no up and down, but yeah, there is definitely um, in and out, but there isn't an up and down. But I'm going to use that analogy anyway and say this is looking from above. So yeah, there's just some really interesting patterns there that I find fascinating, and of course these change as well. So this was for a particular month. Um, the I think this was for like September of 2017, and October of 2017 would look similar. It would have the similar kinds of patterns because we're dealing with orbits that more or less um, repeat themselves, but the shapes are going to be slightly different, and um, uh, and the patterns are going to be slightly different as well. So they're all unique. I was just checking to make sure my sound was still good. Yeah. Anyway, so there's one of them. That is going into the show. Here's another one that is also going into the show. And these I call orbital snowflakes. So this is using exactly the same data, exactly the same, just represented in a different way, and of course presented in a different way as well. I put this in a 3x3 grid, so I sort of call this a study, right? An orbital snowflake study, and yeah, I think those are kind of neat, and you're sort of seeing the same kind of thing. Maybe you can best see it in this one here. Here's and I can zoom in on these a little bit. They don't look too cruddy zoomed in. Definitely low res versions of these don't do them justice at all. But you can see here's the orbit of Io again. Here's the orbit of Europa. Here's Callisto or Ganymede, and here's Callisto around there. So I hope you like those. People who I've shown these to have never seen anything like quite like this before. So hope you sort of like that. I do. And let's see this one. This is sort of a different set of data altogether. This is what I'm calling a magnetic labyrinth. And let me take another drink here. So this is using data from the Juno spacecraft that is orbiting Jupiter at the moment. It's taken with an instrument called a magnetometer. I believe it's called a flux magnetometer, if I remember correctly. And what it does is it measures the strength of the magnetic field uh, in in the vicinity of Jupiter. So this spacecraft is orbiting the planet, and it is collecting data as it orbits the planet. And in this case, the data is magnetic field strength, and it's magnetic field strength in the x direction and in the y direction and in the z direction. So, I took a little bit of artistic license there and separated out the x, y, and z axes. But then this outer ring, which is the colored one, see, this is all grayscale, right? You can sort of look along this and see how the magnetic field changes as you move along these sort of paths, right? But these are grayscale because this is this one here is just the magnetic field in the x direction. This is the magnetic field in the y direction, and this is the magnetic field in the z direction. So those are all sort of, single value type things. So they're grayscale, right? But, well, since I now have 3 grayscale values, I can actually combine them and say that this is the red one, and this is the green one, and this is the blue one, and I can combine them, and what I get is that. So I think that's pretty nifty. I think that's pretty cool. And these shapes, sort of like these rings here, that's actually real to the data as well. That is that's sort of the path that the spacecraft is taking as it orbits Jupiter. So you can sort of see. I don't know if it's incredibly easy to see, but these two, if this were connected over here, it wouldn't exactly line up. It would probably be a little bit off to the side there, and that's because of the motion of the spacecraft. So it's coming in. I think it's coming in to the planet at this point. It's getting closer and closer and closer. So it starts again. This is sort of it's not exactly looking down on the planet this time. It's hard to represent it that way, but if you just look at one path, this end is a little bit further out than that end. So it's getting closer to Jupiter as it's making this kind of a motion. So the artistic license here is combining these 3 grayscales into a color path. It's also making this ring smaller than this ring, and smaller than that one, and smaller than that one. It's also rotating these a little bit. In truth, all these openings would line up, but I think it's kind of interesting to rotate them around, and that's how I get a labyrinth or a maze. So yeah, those are the 3 print entries that I'm entering, and yeah, this is astronomical data. It's but it's art as well. And as I said, yesterday, looking at the journal articles and looking at a lot of the pictures and the plots and the diagrams in just the regular old journal articles, I see a lot of artistic kinds of things in that. So definitely check those things out. All right, well, cool. I'm going to run, see how that looks. This will be a little experiment to see how good or how bad this looks on the live stream does with that. So I'm watching the live stream over here to see. Yeah, it's a little jerky, but yeah, you'll get the idea. You'll get the idea. So this is just, showing that we've got a pretty dynamic thing going on there. And I run through a number of these. Yeah, the live stream doesn't really seem to do it justice because you can't see the motion really well. At least what I'm seeing. But maybe you'll get a little bit of an idea of that. There's some rotation going on there for sure. And the human brain tries to pick out patterns and sees all kinds of stuff in that, especially when you can really see the motion going on. But yeah, again, this is the same data as the first two renderings I showed you, using exactly the same data. Just again, it's represented in a different way, and in this case, a different format. Um, in this case, a video. This is like a 5-minute, 27-second long video. Don't necessarily have to run the whole time. What I'm going to do really quick is check my audio. Yay. We're still good on the audio. So these are just some samples. They're like 29-second long samples of different for different aspects of the same data, but they all look a little different, and they're all doing slightly different things. But yeah, that looks pretty good. Hope you're liking it. This is astro-art. So this is combining astronomy and art, and I find that very satisfying, and I can actually take the same data and make music with it as well. So that just adds another dimension to this whole thing. It's the whole audio visual thing, and in addition to the sound, all this data is actually multidimensional in that there's a temporal aspect to it as well. So in theory, I could 3D print these things, and one could hold these objects in their hand, um, in your hand. So I'm thinking about that. Uh, Thinking about trying a little bit of that, see what happens. Yeah, I hope you like that. It's the live stream, at least the live stream that I'm seeing isn't really doing them justice. Um, but I hope you get sort of a good idea um, about what I'm trying to show here. Just it's it's an amazing universe, and I want to show it off. So this is partially how I'm doing that. Hope you like it. This this video, I'm not exactly sure how they're going to be showing this video. If it's going to be like on its own. I mean, they're supplying everything to show this video. So I'm not exactly sure if it's going to be like on a continuous loop, or if this is going to be combined with the other um, videos that are going to be in the show, and so this will just be part of that. If it's going to have its own screen, I don't know. This is sort of a new thing for me, and we'll see how it goes. How it goes with that. Almost done, it looks like. But yeah, some pretty cool patterns arise just by connecting the positions of the moons in different ways. In this case, there's sort of a buildup. I start with a few connections, and then I just build it up and build it up and build it up. So yeah, so this is on a loop. So we're just gonna go back again. But I hope you like that. Hope you like that. All right, I'm gonna go back to the to the uh, to the ugly mug, and I'm going to stop the video player, and I'm going to get out of that, and then I'm going to get back over here. There, we are back. All right. Well, I hope you like that. That's sort of a aspect maybe of astronomy that that you don't see every day, and that's what this show is all about. It's um, filling some voids that I've observed that are out there, and so hopefully that's what this is doing. If you've got this kind of stuff to share, I would definitely like to see it, and with your permission, I'd like to show it on the show as well. Um, so yeah, those of you who are watching now or watching in the future, um, definitely, if you're working on some interesting uh, things that you sort of consider artistic, um, and want to show them off a little bit, maybe get some feedback, um, send them over. Um, that'd be really, really great. Yeah. So what else do we have? Do I have tonight? Definitely talked about archive.org. And as I said, that's a daily updated um, thing with just the bleeding edge of astronomical and other um, research. There's also sort of an alternative to that. I don't know. Let's just go over there. I'm going to share again, and see if we can find out what this other site sort of portrays themselves as. So archive.org is, of course, ARXIV. The sort of the alternative to that is called vixra.org, which is just archive backwards. Thought that was pretty clever. Let's see if they give any kind of explanation as to what they're trying to do. Doesn't look like it. It's these are yeah. I'm gonna have to find out exactly how Vixra is portraying themselves, because I I want to say that these were sort of the papers that were rejected, but I don't think so. I don't necessarily think so. But as far as I'm concerned, everything's up for grabs, and you know, uh, if if the intention is good, then there really isn't a bad paper. Um, and people put a lot of time into these things, heck of a lot of time. Um, but uh, so they at least deserve a little bit of respect at first. Um, I'm all about being open-minded and skeptical, so I'm more than happy, to sort of hear about anything, read about anything. Uh, but rest assured, I'm going to I'm going to try to rip it to shreds, um, because that that's what scientists should be doing. They should be ripping things to shreds, looking at it carefully, trying to see if it passes muster, right? All of that. Anyway, yeah, these are a little interesting. The speed of dark matter. Hmm. Hmm. Winds outside black holes. New bounds on axions. This is a little far out. Not incredibly far out. There's another site. It's called Progress in Physics. Now, Progress in Physics is out there for sure. But this is a this is an awesome journal, and yeah, they still have the first quarter of 2018 up, and if you look at the titles here, it's just some pretty far out things, and hey, that's where everything was at one point. Everything was this far out, impossible uh, idea, and well, see where we are now. Don't know, but we're somewhere. So yeah, definitely check those out. Progress in physics, as you can see on the right here, has been going on for a long time. So there's a lot of material here, and it's all pretty far out stuff. Pretty far out. Um, Again, these people are um, putting some blood, sweat, and tears into these things. Spending years and years and years trying to develop these ideas, which is culminating in a paper that is published. And yeah, again, it's worth at least a little bit of respect and a good, hard, open-minded look. Um, Quantum gravity aspects of global scaling and the seismic profile of the Earth. Wow, what does that? What do those have to do with one another? Who knows? But all these things are free as well, and you can get into them. You can actually even contact the authors and harass them. I'm sure they'll enjoy that. Authors do to like to hear feedback. They like to have feedback. Um, uh, yeah, I mean, when I contact an author, one of the first things I do is say, hey, you know, I read your paper on so and so, and or I read your dissertation, or whatever it is, right? And every single time the reaction is like, wow, thanks for reading my thing. I don't think anybody read that. So and it's really true. The papers that I've um, authored and co-authored, I know have been referenced and read and used and everything else. But you don't think of that thing. You just sort of think that, okay, I'm going to put this out there and you know move on. Anyway, so most of these are extremely interesting, and this is really progress in physics is very serious, very serious. It's not woo woo at all, um, uh, but it's out there. It's definitely out there. It's most of this stuff is flying over my head by miles. But you know, as I said, get into it. Look at the pictures, read the captions, see if you can get anything out of it at all, and use this as a springboard for your own discovery um, and investigation. And yeah, I have no idea what they're talking about here at all. I'd have to get into it, read it a little bit more, of course. And the neat thing about all these papers is the references. You can come along here, and you're reading about whatever it is. I'm trying to find a reference. Uh, uh, yeah, so you're reading this, right? In 16 was shown that the fundamental metrology is completely compatible with Planck units. Well, there's two references there. So you can go to number 16 and you can, it's a full reference to a Progress in Physics article that talks about whatever the subject is that they were discussing. So yeah, just very very awesome stuff. Very awesome. There's um, all of this is free, and you can spend days reading all this stuff, days and days and days, which I have done and will continue to do. All right. Well, we've hit the 1 hour mark, and I'm wondering how the chat is going. Okay. And I'm wondering if I need to do anything more tonight. As I said, tomorrow is canceled. I'm going to be in a sweat lodge tomorrow night. So that'll be interesting and fun and very, very cleansing. That's always really, really nice. It's sort of like, it's almost like being reborn. It's very, very intense, but very, very cleansing. So that's always a nice thing. So, all right, I think I'm going to get out of here for this evening. It's been a good hour. Showed a little bit of art, talked a little bit about some journals. Um, this is a daily show, so it's very casual. It's very easygoing. There's no pressure, right? I don't feel any pressure at all to, try to pack in a lot of information really, really fast, give explanations for things and all that. It's a daily show. If we miss something today, I'll pick it up tomorrow or the next day for sure. Um, so, yeah, I think I'm going to leave it at that for tonight. I hope everybody has a great evening and a great day. And yeah, no show tomorrow, no live stream tomorrow at all, but the day after. So 0 hours UTC on the 29th of January at 2 hours UTC. So you're going to have to figure out what time that is for your location, because it probably isn't going to be 2 a.m. everywhere on the planet. It's going to be some other time. So you're going to have to figure that out because I can't tell you where you are. That's you. Okay, I'm out of here for now, and thanks for stopping by. We will do it again. I'm looking forward to it. This is a circle of friends, and it's a growing circle of friends. And I definitely want to get to know every single one of you. Hello for those of you in the future. Please stop by live when and if you can. If you can never, watch the recorded shows. They're all going to stay up. Shouldn't have to get rid of them at all. And yeah, I think that'll do it for tonight. Hope everybody has a great evening. Um, yeah, I think I'm going to get out of here. Go back up. All right. I will see you in a couple days. Okay. Peace out.